Hi friends! So for today's video, we're going to start looking at trig applications. Before we do so, I would like you to pause this video and please try these 3 do now questions. All right, let's take a look at the first one. So for our first one, my amplitude is 4. My amplitude is not -4. Remember that our amplitude is always the absolute value of the number written in front of the function. My b value is the number in front of our x, so that is 3. Period is 2 pi over b, so 2 pi over 3. My midline is whatever that shift up is. So for this graph, it shift up 3 units, so my midline is y equals 3. To find my range, I like to take that midline, so take that value of 3. And I want to see how far up and how far down it's going from that midline. So I'm going to add my amplitude, which is 4, to get my maximum value. And then I'm going to take that midline and subtract my amplitude, which is -1, to give me my minimum value. So that is how I get my range. All right, let's take a look at number 2. Amplitude is 2, frequency is 2, my period is pi, midline is equal, lost my equal sign here, midline is equal to -2. My range, again, I'm going to take whatever that midline is, so this graph was shifted down 2, and I'm going to add my amplitude to get my maximum value, and I'm going to subtract my amplitude to get my minimum value. Again, we always write our range, our lowest number, and then our highest number, and I'm using these brackets because those values are included. There is a point on the graph. Okay, and number 3, check your answer. Amplitude is 1/2, b is 1, my period is 2 pi, midline is 2, and then again adding and subtracting that amplitude to get our range. Okay, so before we jump into the applications, I just want to review the general form for trig equations. Just to remind you that the coefficient in front of the x always needs to be 1. So that number in front of, inside of that parentheses with the x needs to be 1. So our b value should always be factored out in front of the parentheses so we correctly can see the shift left or right. So let's take a look at and identify the phase shift in these 2 questions. So again, there's a 2 inside my parentheses here. I need to factor that out so I could see correctly what my phase shift is. So I have y equals sine of 2. And in parentheses, I'm going to divide both of these by 2 when I factor that out. And I end up with x plus pi. I now can see that inside I have an x plus pi. So this means it's going to shift. Inside is always opposite, so it's going to shift left pi units. All right, let's take a look at the second one. Again, I have this 4 on the inside. In order to identify that shift left or right, I need to factor that out. So I have y equals 3 sine of 4. I need to divide both of these by 4. So I have x minus. Now, on the side, if I do pi divided by 2 and divide that by 4, I need to get rid of this 4. So dividing by 4, I could get rid of that by multiplying by 1/4. I'm going to multiply the top by 1/4 also. And I could multiply across the top now, and I get pi. I can multiply across the bottom, and I get 8. So pi over 2 divided by 4 gives me pi over 8. Now, if you want to do that in your calculator, you can. You just can't type in that pi. So if you wanted to do it in your calculator, you can type in 1/2 and divide by 4, and you would get 1/8. And then you just need to know to put the pi back on your top, on your numerator. But it is important to kind of know how to do that by hand as well. So now I have nothing in front of my x, or my coefficient is 1 in front of the x. So I now know that this is going to shift. It's a negative, so it's going to go right. Pi over 8. Okay, for the next 2, they want us to state the period of the following equations. So in order to do my period, I know I take 2 pi and divide it by b. But if I look at these equations, something's a little different, which is going to lead us into today's lesson. My b value is actually a value with pi in terms of pi, so pi over 2. So if I were to calculate this b value, and I did 2 pi divided by my b value, which is pi over 2, this looks a lot different than just simplifying the fraction here. So again, if I take a look at what I did on 2, in order to get rid of that in my denominator, I could multiply by 2 over pi, which cancels that out, and I'm going to do the same on top. So this is really 2 pi over 1. I'm going to multiply across the top. So 2 pi times 2 gives me 4 pi. 1 times pi gives me pi. And I cancel this out, and I get an answer of 4. So my period is 4. I just want to, for a second, recall what our period actually is for these trig functions. My period is my length of one cycle. So if I were to graph this sine function, one cycle would be completed in 4. And since we're going to go into real-world applications, usually our x-axis is set up in some type of time. So let's say that this is for seconds. Once we start getting into these applications of values that increase and decrease and increase and decrease, like these sine and cosine functions, it's going to have to be an x-axis that has numerical values that do not have pi in it. It wouldn't make sense for something to complete something in 4 pi seconds. It makes more sense if it's just 4 seconds. So for these questions, for these applications, our b value is going to have pi in it, and my period is not going to be in terms of pi. So let's take a look at another example. If I want to find my period, I do 2 pi divided by pi over 6. I'm going to multiply by 6 over pi here to cancel that out. I'm going to multiply by 6 over pi here as well. This 2 pi is really over 1. So 2 pi times 6 gives me 12 pi. 1 times pi gives me pi. My pi's do cancel out, and I get 12. So my period for this one is 12. Again, if I just draw a quick little sketch, this is a negative cosine function, and that period, or your one cycle, would be in 12, whatever the units are, so 12 seconds or 12 hours. So the next 3 questions are going to be graphs, and we have to write the function, which is something that we've done. But if we look now, this axis, our x-axis, is numbers that are not in terms of pi, which some of you are probably very happy that it is not in terms of pi anymore. But what that means is when I have a b value, it will be in terms of pi. So in our equation, we will have a b value in terms of pi. So same kind of rules. Let's first figure out, is this a sine or a cosine function? So it's starting up at my maximum. This is what my one cycle looks like. This indeed is a cosine function. Figure out our amplitude. So find your midline, go up to your maximum. So my amplitude in this case is equal to 6. And then we have to find our b value. So I always like to think, okay, what is a formula I know that has b in it? Our period formula has b in it, which is 2 pi over b. So if I look at this graph, I know that that's my formula for my period, and that has b in it. So if I know my period, I could set it equal to that and solve for b. So let's look at my graph. Again, your period is your length of one cycle. So my period is 3. And I could put this over 1 and cross multiply. So I have 3b equals 2 pi divided by 3. And I get b equals 2 pi over 3. Now, I have to find my b value that way, because if you think of your definition of your frequency or your b value, it's how many cycles in 2 pi, which now my x-axis is not set up in terms of pi, so I can't visually see how many cycles are in 0 to 2 pi. So I do need to use this method of finding what my b value is. Once we do that, we now can write my equation, Again, an equation needs to have some type of equal sign. So y equals, my amplitude is 6, cosine 2 pi over 3. Now, just be careful when you write this. You do need to put your x value in there, but in this case, because it is some type of real-world application, your x value is t, not x. So this is time. So just make sure that you are putting a t there and not an x there. And this is my final equation. All right, number 6. This graph is showing the deviation from average daily temperatures for the hours of a given day. So if you think of the temperatures throughout a day, first the temperatures go up and then they go down. And the next day the temperatures are going to go up and increase, then they decrease. And it's going to follow this pattern for every day. So this is a real-world application that models either a sine or a cosine function. So if I look, this graph starts at its minimum, goes up to its maximum, and back down to its minimum. So this is a cosine function. But because it starts at its minimum value, it is a negative cosine function. My amplitude, let's find our midline and our maximum. My amplitude is 4. And then my b value, I do need to do that little bit of work to find my b value. And that, again, 2 pi over b is my equation for my period. Look at your graph and identify what your period is. Your period is your length of one cycle. So in this case, it happens at one cycle ends at 24. Put that over 1 and cross multiply. 24b equals 2 pi. Divide by 24 on both sides. And I get b equals pi over 12. So if I want to write my equation, again, make sure you have a y equals. This is a negative. My amplitude is 4. Cosine of pi over 12. And again, instead of an x, I'm going to put a t there. So this is my equation for this question. All right, let's take a look at another one, which is showing electric currents supplied to your home, which is modeled by this sine function. So again, they are telling me it can be a sine or a cosine function. We're always going to write these without shifts if we can. Of course, you could write them as equivalent sine or cosine by adding some type of shift, but it's always easier if I just start with the most basic. So it's starting at its origin. Here is, or at its midline really, and here is one full cycle. So this is a sine function, is a positive sine function. My amplitude is 30. And let's do a little work to find what my period is. Here's my length of one cycle. My equation is 2 pi over b. That's my equation for my period. And my actual period of this graph is 1 over 25. When I cross multiply, I get b equals 50 pi. Again, if you have numbers without pi on your x-axis, then your b value is going to be a number with pi. So b equals 50 pi. And I could write my equation, y equals 30 sine of 50 pi. Again, they have t here, so I'm going to put t. Please make sure, like, pi is not a variable. Pi is an irrational constant. So if you didn't have that t there, that wouldn't be a correct equation. So please just make sure that you have that t there. All right, what I would like you guys to do now is please pause this video. I would like you to try these 8 questions. Nope, just 7 questions. And then I will put the answers up. So pause this video and give these a try. All right, let's take a look at the first few. For 1 and 2, remember that our number written in front of the x needs to be on the outside, so I could correctly identify that phase shift. On both of these, you did need to factor out that b value. On 3 through 5, we were just finding what my period is, so 2 pi over 4. I'm sorry, 2 pi over b. Which in this first one is pi over 4, and I end up with an answer of 8. And then I get 2 and 24. And for 6 and 7, here are my two equations. Again, just some things that I do want to point out on, let's use a different color, on 6. They did give you a t here, so please make sure in your equation you have a t. Also, it's an equation, so make sure that you have that y equals there. Then on the last one, they didn't tell you that that was t or what the variable was, so you can make up your own variable if they don't tell you. So I used x. You could also use t. All right, what I would like you guys to do at this point, there is an assignment for you to try and submit. And if you have any questions, please post on the discussion board. All right, have a great day. Bye.